In the last presentation, we talked about logarithms. We looked at graphing logarithms and evaluating logarithms. In this section, we're going to look at logarithms in more detail and talk about properties of logarithms. So recall that logarithms are basically the exponents. And so all of our rules of exponents have similar properties of logarithms that will apply. So our basic rules of exponents, if you recall, we had the product rule. The product rule said that when you multiply two things with the same base, we add the exponents. So when we combine, we add. Our property of logarithm, we also have a product rule, and it's going to be the opposite. If we take the log base b of m times n, we can separate this into log base b of m plus log base b of n. So note that multiplication becomes addition, but the rule is when we separate, it turns into addition. We also had the quotient rule. The quotient rule said that when we divide things with the same base, we subtract the exponents. Similarly, we have one for the properties of logarithms. If we have log base b of m over n, this is equal to log base b of m minus log base b of n. And so when we separate them, we subtract. We also had a power rule. B to the m raised to the n is equal to b to the m times n. For our logarithmic rule, we have log base b of m raised to the p. What we do is we take our p and we move it to the front, so we get p times log base b of m. Now, just like when we worked with roots, we said sometimes we combine and sometimes we separate. We're going to do the same thing with our logarithms. So let's go ahead and practice converting back and forth between sum, difference, and product, and single logarithms. So in this first example, we're going to want to write as a single logarithm. So for example A, we have log base A of 5 plus log base A of 14. So remember that plus and multiplication are going to be our conversions. So in order to convert this to a single logarithm, we're going to convert our addition into multiplication. We get 5 times 17. 5 times 14. And if we go ahead and multiply 5 times 14, we get log base A of 70. For example B, we have a subtraction. Remember that subtraction becomes division. So when we convert to a single logarithm, this is going to be log base A of 17 over 6. And for our last one, we have 4 times log base 2 of 3. So to convert this, we're going to take our number in the front, we're going to put it in the exponent. So we get log base 2 of 3 to the 4th, and 3 to the 4th is 81. Okay, so that's converting to a single logarithm. Let's go the other direction now. So in this set of examples, we want to write as a sum or difference of logarithms with coefficients. So example A, we have log base b of 3 times x. So multiplication becomes addition. This is going to be log base b of 3 plus log base b of x. For example B, we have log base 2 of 25 over 13. This is a division problem. Division turns into subtraction. So this is going to be log base 2 of 25 minus log base 2 of 13. And our last example, we want to write this with a coefficient instead of an exponent. So we're going to take our 8, move it to the front, and we get 8 log base a of r. Okay, so hopefully you guys have the basics of this. So now let's go ahead and apply this to more challenging problems. So in these examples, we want to write as a sum or difference of logarithms with coefficients. Now, the basic rule is whatever is on top will be positive, whatever is on bottom will be negative. So when we go ahead and separate this out, we get log base b of x cubed minus, because y is on bottom, it'll be a minus, log base b of y. Z is also on the bottom, so this is going to be minus log base b of z. Our last step, we want coefficients instead of exponents, so I'm going to take my 3, move it to the front, and we get 3 log base b of x minus log base b of y minus log base b of z. This is written as sum and differences with coefficients, and so we are done at this stage. Let's try one more. Let's try log base a of the 4th root of x, y over z cubed. Okay, so remember that roots are essentially the denominators of our exponents. So when we go ahead and convert this, the first thing I want to do is get rid of the root. So I'm going to have log base a of x, y, z cubed raised to the 1/4. I'm going to go ahead and distribute my 1/4, and we get log base a of x to the 1/4, y to the 1/4 over z to the 3/4. Now we can go ahead and write as our sum and differences. So we get log base A of x to the 1/4. Y is on top, so it's going to be plus log base A of y to the 1/4. Z is on the bottom, so it's going to be a minus log base A of z to the 3/4. And for our final step, we want to move all of our exponents to the front. So we get 1/4 log base A of x plus 1/4 log base A of y minus 3/4 log base A of z. Okay, so that takes care of doing some separations. And so now we want to go ahead and talk about combining logarithms. So for these examples, we want to write as a single logarithm. So we're going to do the exact opposite of what we did in the previous slide. The first thing we want to do is we want to move our coefficients up into the exponents. So if we do that, we get log base A of x to the 1/2 minus log base A of y to the 7th plus log base A of z. All right, we can go ahead and combine now. Remember, if it's a plus, it goes on top. If it's a negative, it goes on the bottom. So we get log base A of x to the 1/2 goes on top. Y to the 7th goes on the bottom. Because the z is plus, it will also go on top. Now I'm not sure if the book is going to want you to convert into radicals. So for me personally, I would say you can leave it like this. But just to show you what it looks like with radicals, this is going to be the square root of x. Make sure that your square root ends at the x times z over y to the 7th. Okay, let's try one more. For example B, we have 3 log base b of x minus 4 log base b of y minus 1/3 log base b of z. So again, same thing, we're going to go ahead and move all of our coefficients up to be exponents. So we get log base b of x cubed minus log base b of y to the 4th minus log base b of z to the 1/3. All right, when we combine into a single logarithm now, we get log base b x cubed is positive, it will go on top. We have minus log base b of y to the fourth, so our y to the fourth will go on bottom. We have minus log base b of z to the 1/3. That means z to the 1/3 will also go on bottom. And then to write with radicals or roots, remember that the denominator becomes the index, or what kind of root it is. So this is going to be log base b of x cubed over y to the fourth, and this becomes a cube root of z. Okay, so that takes care of our properties of logarithms. Now, when we look in the next section, or in general, we generally just combine logarithms when we get out of this section, but it is important to know how to convert back and forth between the two, either going from a sum or difference to a single logarithm. Okay, so we're going to take a break and then we'll come back and look at solving exponential and logarithmic equations.